Hello, and welcome to orientation for physics, AP and honors physics with Dr. Von Moss. Um, it's good to actually get a contact with you guys. I'm excited to get started. So let me go ahead and start the slideshow because it helps to see what's going on. All right. So, as I've already said, this is AP and honors physics orientation with Dr. Von Moss. So, as you've already seen me, that's me, but I probably need to update this picture for this slide because that's when I graduated grad school. So it's been a little bit since then. So I'll tell you a little bit about my education background. I got my bachelor's degree from the University of Florida in physics. Then I got a master's degree from Florida State in physics. And finally, I got my PhD in nuclear physics from Florida State, all in one run. And then after Florida State, I went and did some postdoc studies at Oak Ridge National Lab for a little over a year, I think 15 or 16 months, working with the Global Security and Nuclear Science and Engineering Directorates in Tennessee. So that was a lot of fun. That was an interesting place. And after that, I took up teaching. So this is my 5th year teaching, and I've taught the courses that you can see on there. IB, AP Physics 1. This is my 1st year teaching honors physics. And I've been with Orlando Science this is my 3rd year of those 5. So personal life, I grew up in Florida, spent almost my whole life here except for that year in Tennessee. I've been married for 10 years now, as of 2 days ago as of recording this. And I don't have any kids. I do have a German Shepherd. That's what he looks like. That was taken a few years ago. He's got a little more gray around the muzzle now. And my favorite book series is The Lord of the Rings, which is just fantastic. It's fantastic. Some of my hobbies. This is not in a total list. I have a lot of other things I enjoy doing. Unfortunately, I just never have enough time to do it all. I enjoy violin, which I'm terrible. I've been trying to teach myself the violin for years now, and it usually ends up being like I play it once a month because I don't have enough time, or I don't know, it's just hard to get myself to do it all the time with life. I probably have times I could do it, but never really work on it. I enjoy disc golf, board games with friends. It's a lot of fun, and I am a huge nerd, so any sort of academic conversation that you want to get me going with, English, history, any science, of course, any science or math. A few years ago, I decided to have a little fun with some students, and so I spent a good little while between classes. In the halls, I'd see students, and I'd argue with them that we should be using base 11 counting systems instead of base 10, which, of course, it's a little bit silly, but it was fun. And some of the students got into it. Like, one of them came back to me with a really good argument for why we should use base 12, which is actually way better than base 11. I need to cut this out. No one wants to know this. My teaching philosophy. So I believe in teaching physics by doing. That it's a science. It's a hands-on practical science. And you need to actually do it to learn it. You can't just watch someone else do it. You can't watch me do it. You can't watch your friends do it. You have to do it. And that goes with labs. That goes with the actual activities, like the actual problems. Like, because one of the big things that you learn is how to solve problems. And if you're not solving those problems, then you get nothing out of it. You can't learn problem solving by watching someone else. I mean, maybe it helps slightly, but you've got to struggle through it. So I really believe you have to learn physics by doing it. So I also try and put a lot of focus in my class on being able to explain what happens and provide evidence for why you think that, and support those claims with reasoning and saying, so like if I asked you like what happens or why, you should say, have a claim and say this is what happens because of this. Like, so here's the relevant rule and that's why it applies, right? And then I'm also real big into the math and being able to solve problems numerically. All right, so there are 3 types of labs that we do. So they're procedure-driven labs, and they're create-your-own-procedure labs, and then there's just create-your-own-question labs. So procedure-driven labs, you want to follow, it's going to be like you follow these specific steps. That's the standard lab that you would get in most places. Do step 1, step 2, step 3, and then you're done, right? And so it's very, methodical. And that's going to be used more for like brand new topics or complicated questions, things that require that specific procedure. But then for the create your own procedure labs, I'm going to say, go answer this question. Here's your question. I want you to figure out what is the acceleration due to gravity. Here's a bunch of tools. Go figure out how to answer that question. And then that's going to be something people are going to do. And then finally, the 3rd type of lab, which is those create your own question labs, is going to be, I'm going to say, today we are going to investigate gravity. What question would you like to ask about gravity? Pick a relevant, interesting question that we haven't done before, and then go out and answer it. And I think those are really useful and real interesting. They're fun too, because students get to pick something that matters more to them, but like it's theirs the whole way through, right? And I think that can be important too for the learning process. All right, let's go to the next one. So because we're doing this as an online class, there's going to be a lot of online labs, which, I mean, it restricts us some. So we're going to be using things like PhET, which is Pivot Interactives. Sometimes I'll record a demonstration that I do and just tell you the numbers, and you can work with those numbers and practice the analysis. And there's going to be other assorted simulation websites as I find, like Falstad or something else. Okay, so assignments, of course, are all going to be online. They're going to be either through your online textbook, OSS Connect, AP Classroom, Albert.io, maybe Study Island, depending on which class you're doing. And then you're going to submit them either through that website you're doing it on, like if you're doing it on AP Classroom, you're going to submit it on AP Classroom. Or if it's something else, like a lab, that's like, I think Pivot Interactives, you can submit the lab on that website. But if you're doing the lab, a different kind of lab, like a PhET lab, you're going to probably write it up in Microsoft Word or Google Docs or whatever you have, and then download it and then attach it to a submission on OSS Connect. And then, don't email me your assignments, because by the time I get to like grading everyone else's, I'll forgot that there's one of them in my email, and then it'll be like another week before I get it graded. And so it's just better to submit through OSS Connect, and also everyone can see it's there. No one's going to lose it. It's great. All right, ways to contact me. I'll leave this one up for a second. So my email is justin.vonmoss@orlandoscience.org. This is the best method of getting in contact with me. I check it usually more than once a day, usually in the mornings and in the afternoons. And then Microsoft Teams is good for conferences, so you can email me, schedule ahead, we can get on and have a conference. And if that's not working well or we need something else, I can look into trying to find other methods for communication and other ways of getting so that you can get a hold of me. But I think that's going to work pretty well for us, and you can let me know if you think it is or isn't. All right, and that's all we've got. So it's a pleasure to get a chance to talk to you in this video. If you have any questions, let me know, and I am available in the chat. All right, let's go ahead and end this.